Good morning, Year 11s. Excuse my voice, I'm not feeling the best. So last lesson, if you were here, we looked at permutations, and that was just an arrangement of a collection of objects when the order mattered. So for argument's sake, if you had the letters A, B, C, you could arrange them into pairs in how many different ways? So pairs, there would have been 3 in the first spot and 2 in the second spot. So there would have been 6 different permutations. There would have been AB, AC, BA, BC, CA, and CA and CB. 6 different permutations.
Could you try again?
So there's 6 different permutations where order does matter. We could also use this formula here. So for argument's sake, P, where we have 3 objects and we're picking in pairs, groups of R, or 2 in this case, then it's going to be n factorial, which is 3 factorial, divided by n take R, so 3 take 2 is 1 factorial, and 3 factorial is 3 times 2 times 1, divided by 1 is also just 3 times 2, which is 6. And I showed you how to get to the permutations on your calculator. So just a quick recap of permutations. So, I wanted you to have a go at this opening problem before you watch this video. So, if we have 3 people, A, B, and C, and we want to make pairs of 2, how many different pairs are there when the order doesn't matter? Well, you could pair people up into A and B, A and C, but there's no point having B and A because they've already been paired up because the order doesn't matter now. And then there's also B and C. There's no point doing C and A and C and B because they're already paired up. So there are 3 different pairs when the order doesn't matter. And how does this relate to the number of permutations? Well, there was 6, so there's half the number. Yeah? Half the amount. Or divide the number of, to find the combinations, you had the permutations, half the amount. Or you had the permutations divided by the number of divide by 2. Now, if we have 4 people and we want to make pairs of 2, how many different pairs were there? Well, you should have got, if we had 4 people now, so we would have had person A, B, same as before, A, C, but now we had A, D, and we would have had B, C, B, D, and then we would have had C, A and B is already done, so C, D. So we would have had 6. And then again, if we worked out the number of permutations, so the number of permutations would have been 4 times 3, which is 12. So again, skipped a couple slides. So again, the number of combinations is half the number of permutations. So could we make a conjecture? So something reasonable that you would have seen from the 2 patterns, so the numbers were 6 and 3. So the number of combinations is half the permutations, and you would have had 12 and 6. So a fair conjecture would have been that the number of combinations is half the number of permutations. And then, if you tested it, so for 5, so now we would have had AB, AC, AD, AE, BC, BD, BE, CD, CE, DE, and then these are all covered. So we would have had 4 plus 3 is 7, 8, 9, 10. 10 combinations. And then the permutations for this, so that's the combinations. The permutations would have been 5 people, so it would have been 5 in the first slot, 4 in the second. So it would have been 20. And again, the number of combinations is half the number of permutations. Now, we could have even furthered this investigation, and we could have looked at groups of 3. Now, does anyone want to guess what the relationship would be? Do you think some of you might say, well, you divided by 2 this time because we were in pairs? Some of you might guess that we would divide by 3 to go from permutations to combinations for groups of 3. But that wouldn't have quite worked. So what actually happens is this. To find the number of combinations or selections, first count the number of permutations and then divide by the number of ways in which the objects can be arranged. And if you're in groups of 2, they can actually be arranged 2 times 1, so 2 factorial ways. But if you had a group of 3, so if you had 3 people, they can actually be arranged in 3 times 2 times 1 ways, or 3 factorial. So we actually divide by the number of ways in which they can be arranged, which is the number of the group factorial. So anyway, this brings us to our combinations formula. Sorry, I completely lost my train of thought. I had to stop it for a few minutes. So anyway, if we want to find the number of combinations, first we can find the number of permutations and then divide by the number of the objects that they're being arranged in, factorial. So this number of permutations on the first slide was this part here, n factorial divided by n take r factorial. And now we're just dividing by the r factorial, which is the number of ways in which the objects can be arranged. So this here is the formula. So if we ask you to use the combinations formula, you'll need to use this. Getting a little bit complicated, but it's not too bad. So for argument's sake, we worked out on the opening problem, so the number of combinations if we had, let's change colour on me. Let's go back to blue. We had the number of combinations on 4 people, and we had them in pairs. So that would have been, if we're using the formula, it'll be 4 factorial for that, and then n take r will be 4 take 2, which is 2 factorial, times by r factorial, which in this case is 2 factorial. Use brackets when using your calculator. So it'll be 4 factorial. If you can't remember how to get to factorial, you hit option, then you go arrow, which is F6, then you go probability, which is F3, and then you hit the factorial button, which is the X with the exclamation mark. So it's 4 factorial, and then divide by, use brackets on the bottom line. So it's 2 factorial times by 2 factorial, and you get 6, which is what we had from 4 people. Yeah, we had 6. And again, we can do this, so you'll notice that you have, so next to the exclamation mark on your graphics calculator, you also have the permutations button, and then you have NCR, which is for combinations. So rather than using the formula, we could have just wrote 4, and then NCR, and then 2, and then that'll also give us 6. So the number of combinations from 4 people in groups of 2 is 6. This notation here is another way of, so instead of writing C and R like this, this is just another way of writing it with brackets like this, N over R. The textbook uses that notation. So does the say subject outline. I skipped over this. So combinations are sections of objects where the order is not important. So when you're putting people in groups, order is not important. So some classic examples are placing people into sporting teams or different committees. So when we're selecting R objects from a total of N objects, we denote this as CNR. And this is often read as, so here we're choosing 3 objects from a total of 5. And this is often read as 5 choose 3. So 5 people choose groups of 3. 5 choose 3. So we're going to do a few examples now. The first one we'll do with the formula, but the rest we'll probably just do with the graphics calculator. So our first one, a netball team of 7 players is chosen from 10 available people. And how many ways can the team be selected? So order doesn't matter. So we're obviously trying to find combinations. So 10 choose groups of 7. So it's going to be 10 factorial over 10 take 7, which is 3 factorial, times by 7 factorial. And if you type that into your calculator, you will get 120. And if you just check on your graphics calculator, do 10 choose groups of 7, 120. So if it doesn't tell you to use the formula in the test, you can just, as long as you show this notation, that's the important part. The notation is the important part. Alright, so in some cases, we want to exclude things, exclude certain people or items or objects. So the Uber Cup is the pinnacle of badminton for females, for the female team's event. Australia is playing in a preliminary final tie against New Zealand and must select a team of 6 from a group of 12 that have nominated. So in how many ways can the team be selected if there are no restrictions? So if there's no restrictions, we're going to have 12 players and we're choosing groups of 6. And we can simply just use our calculator for that. So 12, C6, and we've got 924. 924 combinations of choosing groups of 6 from 12 players. Crazy amount. But it is vital, you guys need graphics calculators. If you don't have a graphics calculator, you need to get one ASAP. And there is an option to borrow from the library, I believe, but I think there's a borrowing fee. So look into that. Part B, in how many ways can the team be selected if the captain and then 5 others are to be selected? So this, I just want you to think of this in terms of permutations. So in that first spot, the captain has to be selected, okay? And then in the next 5 spots, we can basically work out the number of combinations using the formula. So how many players are left over if we have to pick the captain? There will be 11 players left over. And then we want groups of, not 6 now, because we've already got the captain, we want groups of 5. So it'll be 1 times by 11 choose 5. So it'll just be 11 choose 5, which is 462 different combinations of selecting the captain plus 5 others from the group of 12. Now, in how many ways can the team be selected if the captain and vice captain and 4 others are going to be selected? Well, again, think about how we're doing permutations. So captain has to be chosen, vice captain has to be chosen, and then we're going to have a pool of 10 players left over, and we're going to choose 4 of them. So it'll be, using the graphics calculator, we're going to have 210 combinations now. Still tons of ways. We only have one more example. So sometimes we can independently pick from different groups. So teachers being selected for a camp. Most camps you need a ratio of male and female teachers. So in total, 2 males and 2 female teachers must be chosen from a pool of 4 males and 5 females. In how many ways can this be done? So I want you to think back to the very first thing we were looking at. And we were looking at, so there was, we looked at the number of ways of selecting different drinks and fruit. So just for argument's sake, say that there was 3 different drinks in the fridge and 2 different pieces of fruit. These were independent actions. So we used the multiplication principle to work out how many combinations there were. So there was 3 times 2, there was 6. So picking 2 males from a group of 4 and 2 females from a group of 5 is exactly the same situation. They're independent actions. So we just need to multiply our results together. So our first thing is we have a pool of 4 male teachers and we're picking 2. So 4 choose 2. And then we need to multiply it by the combinations of female teachers. So for female teachers, we have 1 extra, so there's 5, and we're going to pick 2 of them. Excuse me, sorry. So if we type that into our calculator, we'll have 4 choose 2 multiplied by 5 choose 2. And there's 60 different ways. So 60 combinations of picking 2 males and 2 females from the pools of 4 and 5. Now, part B, a little bit more tricky, if at least one of either sex must be selected. So now we're not saying 2 and 2, we're saying at least one. So there's 4 teachers in total. So our options are 1 male, 3 female. We could also have the same that we just had, the 2 males and 3 females. And then we could also have 3 males and 1 female teacher. So in this case, this is sort of the sum principle where we have to add up the 3 different options. So for the first one, 1 male and 3 female. So if we have 1 male from our group of 4, we're only picking 1. And then we're picking 3 females from our group of 5. Well, if we type that into our calculator, 4 choose 1, 5 choose 3, we get 40. And then for the male one, if it's, oh sorry, this is meant to be 2 and 2. Sorry. Apologies. Hopefully you corrected that. And that's just what we just worked out before, so it's 4 choose 2 multiplied by 5 choose 2, and that gives us 60. And then finally, 3 males. So from our group of 4 males, we want 3, and from our group of 5 females, we only want 1. So 4 choose 2, and then 5, but choosing only 1. So there's only 20 ways to do that. 4 choose 3. So there's 20 ways to do that, and then we would add them together. So 40 plus 60 is 100, so it's 120 in total. So there's 120 different ways of picking at least, so if at least one of either sex teachers goes on the camp. So hopefully that you followed that. Have a go at these exercises in your textbook that you should have picked up from the Learning Hub. And yeah, work with each other to try and get through everything. Thanks.